All right, so we're going to go ahead and talk about how to sketch rational functions. This is where we're taking everything we learned from 5.2 and 5.3 specifically and combining it all together. So these are kind of the steps, and really all it is you need to find everything we've learned how to find. So we need to learn we got to find the holes, the vertical asymptotes, the x-intercepts, the y-intercepts, and the horizontal or oblique asymptote. Sometimes at the end you have to finish with a table, and I'll explain that as we do one of these. So here is an example. We've got x plus 1, x minus 2. So I usually go in this order, but you don't have to necessarily go in this order. You do need to make sure you find your holes before vertical asymptotes, though. So that does have to go, and before your x-intercept. So I do all that. I find my HA, OA. I find my x-intercepts and y-intercepts. Intercept. So there's only going to be one. So that's the information we need to find. I'll just put it as I find it right here. So remember, when it comes to these three, going back to 5.2, you need to factor first. So those are the three that require factoring, which for this specific example, oops, actually moved us. For this specific example, there's nothing that can factor. So whole are common factors, and there are no common factors that we can cancel out, so there's no holes. Vertical asymptote, if you remember, is on the bottom, so it's the zeros of the denominator, so you have x equals 2. And then x-intercepts are the zeros of the top, and it would be x equals -1. So let's go ahead and plot those since we have those. We've got negative or positive 2 for our vertical asymptote, so I'll put a dotted line at positive 2. My x-intercept is -1, so right here on the x-axis. So you just place that on the x-axis. And then the other two you find from the original without the factored. So horizontal oblique asymptotes, you look at this. So the degrees are the same. You divide them out. So x over x is just 1. So you have y equals 1 as your horizontal asymptote. Perfect. So that's that. Y-intercept, you find by plugging 0 in for the x's. There was a quick way you could do that, or you could just go ahead and type or write it in. Either one. The quick way is you just look at the constant of the top divided by the constant of the bottom, and you get -1/2. So that would be right here. Then what you do is if you have points on one side of the asymptote, you just follow the curve along, like so, and follow both the horizontal asymptote and the vertical asymptote. So you don't want to, we're not crossing through those like shown right here. You're just getting really close to both of those. Then the vertical asymptote tells you how many curves you should have. Right now we just have one curve. We should have a second curve so right now we have a curve on this side A. We need a curve on side B, so on the other side of that vertical asymptote. Okay, so for that reason I'm just going to plug in a number. We'll do 3, and I'll plug it into the equation. So 3 plus 1 over 3 minus 2. I chose 3, by the way, because it's to the right of the asymptote. So 3 plus 1 is 4. 3 minus 2 is 1, so this is just 4. So I'm going to go to 3, 4. I'm just going to plot that coordinate right here. And then you just need at least one point. You're going to go ahead and just follow along the curves. And you're done. Let's do another one because it will get a little more complicated as we go. So I'm going to go ahead and do same order. So we've got whole, we've got vertical asymptote, we've got our horizontal asymptote or oblique asymptote. We've got x-intercept, y-intercept, and you don't have to write them in this order. I think, yeah. Okay, so remember, the three that require factoring are the whole, vertical asymptote, and x-intercept. So the top, x squared minus 1, is a difference of perfect squares, so that's x plus 1, x minus 1. The bottom is the grouping method. So the greatest common factor of the first pair is x squared. And then we have x minus 1. Greatest common factor of the second pair is negative 4. And then you once again get x minus 1. So we have x minus 1 and x squared minus 4, which does continue to factor more because x squared minus 4 is a difference of perfect squares. I'm actually going to I'm going to rewrite the top actually. Oops. Just because I want the x minus 1s, we will have a hole in this case because we've got x minus 1, x plus 1, right? And we've got this x minus 1, so notice there's the common factor. So I just wanted them right over top each other. You don't have to do that. I'm just doing that for this video. So we've got a hole right here. So that tells us we've got a hole, which I'm going to do in a different color. So for the hole, our hole is at positive 1. And then remember to find the y value. You just plug 1 in for x. I'll move that over. We're going to plug 1 in for x, and we plug it into everything else that's left over. So we've got a 1 plus 1 on the top, and then we've got 1 plus 2 and 1 minus 2. I'm going to zoom in so you can see this better on the screen. So we've got 2 over 1 plus 2 is 3, so we've got 3 times 1 minus 2 is negative 1. So this is negative 2/3. Okay, let's zoom back out. So 1 negative 2/3, so we go over 1 negative 2/3, that's right here roughly. You just put an open circle for the hole. So we plotted that. Okay, from there, our vertical asymptotes are the remaining two. I'm going to go ahead and put that check back. Put it right here. So we've got negative 2 and positive 2. So there are actually 2 on this one. And positive 2. And then x-intercept is the top, and it's negative 1 because that's the 0 of x plus 1. So then I'm going to go to negative 1, and I'm going to put a point right there. Now, if you recall back when we did polynomial functions, graphing, sketching polynomials, for x-intercepts we always figured out if they bounce or cross based on the exponent. Remember, if it's an odd exponent, it's going to cross. If it's an even exponent, it's going to bounce. So I'm just going to make a note of that. This is an odd exponent, so it crosses. Okay, then we go back to our original function for the remaining parts. So horizontal asymptote you find by looking at the first terms. And since the degree on top is bigger, so it's x squared over x cubed, the degree on top is smaller, that tells us it's going to be y equals 0 automatically every time it's a smaller exponent on top. Then we'll plot that, and I'll do that in red again. Then our y-intercept is where you plug in 0 for all your x's. So you got 0 squared minus 1 over 0 cubed minus 0 squared minus 4 times 0 plus 4. That's just negative 1/4. So notice it's just your constants in the numerator and denominator. So we've got negative 1/4. That's right here roughly. So these points, you're going to connect them. This, I can't have another x-intercept, so it's going to go down. This x-intercept crosses, so I'm going to go through it. So it's going to look kind of like a little cubic function. And you'll know it's like a kind of a cubic function in the middle if it crosses. Now I want you to note that it is crossing your horizontal asymptote in the middle. That will happen in the middle sometimes. On the far ends, you're going to just approach the asymptote. And in fact, we need to figure out what happens in those far ends. So let's go our left side. So this is our farthest left side, section A. I'm going to go ahead and plug negative 3 in. That way I get negative 3 squared minus 1 over negative 3 cubed minus negative 3 squared minus 4 times negative 3 plus 4. I could have also just used the remaining stuff. In fact, let's do that because that looks a little easier. You can either go to the original or the simplified. So we have negative 3 plus 1 over negative 3 plus 2 and negative 3 minus 2. So negative 3 plus 1 is negative 2, negative 3 plus 2 is negative 1, Negative 3 minus 2 is negative 5. So this gives you negative 2 over positive 5. So it's going to be negative 3, negative 2/5, so somewhere around here. So I know it's going to be on this bottom half, so I'll just draw a curve on the bottom half. Then let's do the same thing with positive 3, because positive 3 would be right here, so on the far right. So there's going to be 3 curves, so section A, section B is the middle section, section C is the last section. And I'll use the same function, so I got 3 plus 1 over 3 plus 2 times 3 minus 2. So we got 4 over 5 times 1, or 4/5. So I'm going to go roughly right here at 3 4/5 and draw my curve. And there's the graph.